This video is a visual explanation, not real footage.
Did you know that right now, human-made messengers are traveling in different directions of the universe? Not satellites, not missions that will come back. They're already leaving. No steering, no updates, just moving farther away from Earth, every single second. These probes are not exploring nearby space. They've reached escape velocity, meaning gravity can't pull them back anymore. No orbit, no return trip. Once they passed that line, they officially became runaways. This is Voyager 1, the farthest object humans have ever built. Right now, it's over 24 billion kilometers away from Earth. If it were a commercial airplane, it would need about 27,000 years to get there. Voyager did it without fuel, without updates, and without asking permission. Voyager 2 looks almost identical. Same era, same design, completely different exit. It's the only spacecraft that visited Uranus and Neptune. Same hardware, different life choices. Both of them are leaving us, just in opposite directions. Some of these probes are already silent. No signal, no power, no response. But here's the weird part. Silence doesn't mean stopped. They don't need electricity to move. They don't need instructions. Momentum is doing the job now. Voyager 1 is moving at about 61,000 kilometers per hour. That's not sci-fi fast. It's not warp speed. But compared to you, it's embarrassing. A bullet looks slow. A jet looks stationary. Voyager is basically saying, I left in 1977 and I never slowed down. This is the moment that matters. Once a probe crosses this boundary, the solar system is officially behind it. No gravity pull, no cosmic U-turn. This is not exploration anymore. This is moving out. And not telling anyone your new address. These probes aren't heading somewhere specific. They're just leaving. Different angles, different trajectories, no destination, no meeting point. It's like humanity opened the door, threw a few metal objects into the galaxy and said, "Good luck out there." When a probe goes silent, people assume it's dead. No signal means no control. But control isn't required anymore. Physics took over. Momentum doesn't care about batteries, so even in total silence, these probes are still doing exactly what they started. No engines are firing. Nothing is pushing them. Nothing is pulling them back. They're moving purely because they already were. That's inertia. Once you start moving in space, you don't need motivation. You just keep going. Honestly, same. The first thing that dies on these probes isn't the metal, it's the battery. Voyager's power slowly fades year by year. No recharge, no replacement. But here's the funny part. Losing electricity doesn't stop motion. It just stops talking. Voyager's battery was built in the 1970s, before the internet, before smartphones, before half the countries on Earth even existed. That battery is still producing power today. Not because it's advanced, but because engineers planned for decades, not upgrade cycles. When contact is lost, it feels dramatic on Earth, inside control rooms, inside human heads. But for the probe, nothing happens. No slowdown, no reaction. Silence is emotional. Trajectory is not. In 1,000 years, empires collapse. Languages disappear. Maps are redrawn. But far from Earth, one thing stays boringly consistent. The probe is still exactly where physics predicted. History is chaotic. Inertia is not. Movies make space look violent. Asteroids everywhere, explosions non-stop. Reality? After 1,000,000 years, the probe is barely scratched. Not because it's tough, but because space is mostly empty. 1 billion years from now, Earth may not even look familiar. The sun itself will change, but that tiny probe, still moving. No mission, no message, just momentum doing what it always does best: ignoring time. We didn't just send metal and wires. We sent music, voices, laughter, a polite introduction from one tiny planet. No instructions, no explanation, just, this is who we were. Which is incredibly brave, or incredibly naive. The record includes greetings in 55 languages, music from different cultures, and actual heartbeats. Imagine discovering alien technology, and the first thing you hear is someone saying, hello. No context, no subtitles, just vibes. If someone finds this, they won't know what humans are. They won't know where Earth was. They won't know if we survived. All they'll know is something out there wanted to be remembered. And honestly, that's the most human thing possible. One day, the power will reach zero. No signal, no voice, no heartbeat. But the probe won't stop. Because momentum doesn't care about batteries or civilizations. It just keeps going, quietly, forever. Voyager is moving at about 61,000 kilometers per hour. That sounds fast, until you compare it. A jet plane? Basically parked. A bullet? Still embarrassing. Voyager isn't fast by sci-fi standards. It's fast by human expectations. In an average human lifetime, Voyager travels about 17 billion kilometers. That's not Earth to Mars. That's Earth to numbers stop feeling real. One human life, 17 billion kilometers. And that's just the warm-up. Space looks crowded in photos. It's not. Between stars, there's basically nothing. The chance Voyager hits anything in millions of years is almost zero. Missing everything is actually the default setting. Voyager doesn't need fuel anymore. No thrust, no engines, nothing pushing it. It keeps going because space doesn't slow things down. No air, no friction, just physics doing its job. Cities collapse. Countries disappear. Every building humans ever made will eventually be gone. But Voyager? Still moving. Not because it's important, but because physics doesn't care what matters to us. The nearest star is just over 4 light-years away. At Voyager's speed, it'll get there in about 75,000 years. That's longer than all recorded human history, by a lot. This isn't slow travel. This is cosmic patience. Earth to the moon? Less than 500,000 kilometers. Earth to the sun? 150 million. Nearest star? 40 trillion kilometers. At that point, your brain stops scaling and just gives up. Space isn't crowded. It's basically empty. On average, there's about 1 atom per cubic centimeter. That's less than a vacuum cleaner dreams of. So, will anyone find Voyager? Maybe. Statistically, don't bet money on it. Voyager isn't magic, it's metal, wires, bolts tightened by human hands. No super tech, no alien help, just people who did the math right and let physics finish the job. Yes, the universe is massive. And yes, we're tiny. But something built by humans is already farther than any person will ever go. No superpowers, just curiosity and physics. If this surprised you, you already think bigger than most people. That's worth subscribing for.